Chapter 13 is technical ventilation. So, lesson objective number 1, we're going to describe the reasons that we're going to use tactical. The thing to remember with any type of ventilation that we're doing is it's going to be it has to be very planned, very carefully planned, to make sure that we get the results that we want and not have any incidences that we may not desire. So it's going to be planned, systematic. It's a coordinated removal of the heat, the heated air, any of the smoke in there to help us with visibility, get those nasty gases that we talked about in chapter 5, any other airborne contaminants that may be floating around there too. So we're performing it for life safety measures as the main reason. Trying to get that heat out, any viable life that may be in the structure, it'll help them. Incident stabilization, we're getting the heat out, trying to knock out some of the points of the tetrahedron. And property conservation, which is the second point of fire service, after life safety is property conservation. And we're only going to perform it obviously when we have fire attack hoses and teams in place and ready to attack, because if something does go wrong, we want to have that backup in place so that we have a protection. So, success is basically planned on four different factors. Careful planning. Careful planning is going to come from anything from trainings, making sure that we know what to do, when to do it, everybody's in place, to IC making sure they did a proper 360, that we know where the seat of the fire is and what the plan is to get it out. Knowledge of that building and the building construction itself. Is it just a single family residence? Is it a multi-dwelling? Is it a commercial structure? And that's where a lot of your pre-planning will come into play. If you get an opportunity as part of your fire department and you're looking for something to do on training nights, go out and do pre-plans of some of your structures that you feel may be of high risk. Or may not be so much high risk, maybe just ones that if something were to go wrong, even if it's not high risk, which as a fire threat, but high risk for your safety. Hardly the first thing that will pop into my mind, just because I remember driving by it all the time, was the grocery store. Because that place is so compact with all the other stuff in it, and the way the back room is set up, you've got your main grocery area, you've got the little deli that's off in the front. It used to be, I don't know if it's still there.
They added a lot onto that store.
Right. So, but you go into the back room. Well, there'd be the back room corridor where they do produce, but then off of that was another area. So that rings to me because I've been in that building. Armstrong. I've been in Casey's.
That's about all there is to be in.
Casey's, the golf course. That I know that one. You've got multiple entrances into it. You've got multiple levels, if I remember right. You've got bar area here, seating area here. So just incidents like that you could take an opportunity maybe to pre-plan as a department, to learn about those structures, learn where the hydrants are located and stuff like that. Systematic application of the procedures, making sure that we're doing things in an orderly fashion the way we need to do them, and making sure that we're going to coordinate it with all the other activities we have going on, breaking out windows, setting up a vent fan, cutting a hole in the roof, having a tack line set up where we want them. So we're going to do it for obviously for several different general reasons. We're going to reduce the interior heat levels by pushing that air out, getting that hot air out, decrease the rate of the fire spread, which sounds odd because in some regards when we're using ventilation, powered positive ventilation fans, we're pushing air into it, but we're decreasing it because we're pushing it out into a certain area. Reduce the potential of extreme fire behavior. If we're into the growth stage and we haven't gone into the fully developed stage yet, we're slowing it down so that it doesn't get there. Improve interior visibility. By getting that smoke out, you take an instance where you may be on your hands and knees, and as soon as that smoke starts to clear out, now we may be on a one knee scoot, or you might be able to walk in. You know, the hotel fire that we had in Milford a number of years ago, you know, we walked in, walked all the way up the steps, and we weren't on hands and knees until we got to the second level. You know, I've been in houses where you walked in until you were, you know, maybe 20 feet from the fire room of foraging, and then you'd have to drop down and get a little lower. So it's going to improve our efficiency just for that reason. The faster we get to it, the faster we can put it out. I said about the victim survivability. If we get the heat out of there, if we get the smoke, all the nasty stuff out of there, we put them in a greater chance of survival through the whole thing. And obviously, like I said, we're going to reduce the smoke, and if we can put the fire out faster, we're going to reduce any property damage that may occur from it. Correctly implemented, it's obviously going to increase life safety, like I've stated. It's going to stabilize an incident that may be unstable at some point in time, and property conservation. If we don't do it right, we're going to impact any occupants that may be inside. We'll impact ourselves because we're going to put ourselves into a situation that is going to be unsafe because if something goes wrong and we're not prepared for it, you know, we could easily send a crew of 2 in, and something goes wrong and the fire flares up behind them, and now they're completely entrapped in it. And it can obviously impact the physical structure of the building if we allow impingement into areas that we're not aware of if something goes wrong. Improve life safety. From the get-go, that's the number one thing that we're out to do. You know, it is job number one. I will tell you from experience that your heart is racing when the pager goes off already, right? Okay? Wait till somebody tells you that there's victims inside. Your heart just amps up just that much more. Okay? So when we say that life safety is the number one key, understand that it is a very stressful situation. So, but doing ventilation, when we do it properly, we're going to increase that oxygen concentration because we're putting more fresh air in and getting rid of the bad air, which is our concentration of toxic products. We're going to reduce the temperature because we're pushing all that hot air out. Once again, we're going to increase that visibility. And we're going to create a smoke-free path of egress, both for us and any victims that we find. You know. So here's our stages when we go to extinguish a fire. We got to locate it, obviously. Try and confine it if possible. That could be anything from just shutting doors on your way through. You go through a hallway, you come to a room, nothing in there, shut the door. Go to another room, nothing in there, shut the door. Has everybody seen the videos that are out on Facebook about it, if they got any of the fire engineering or any of that, of the way a room looks in a house fire? One room had the door open, one room didn't. The one room is completely torched and the other one has minor smoke damage. And then the ultimate goal is just to extinguish the fire. How does it influence property conservation? Same thing with life safety. We get the smoke out, we get the gases out, heat out, and we want to, like I said, we want to confine it to a specific area so that it doesn't grow. If we've got enough people available, and I understand that we are in a situation in volunteers where we don't necessarily have a lot of people, you know, and we're not necessarily, you know, Armstrong's not as lucky, Harley, you guys are not as lucky. Terrell, you are, but you're not. But you guys aren't as lucky as we are here in Reynolds Park, Okoboji, because we are literally surrounded by 2 more volunteer fire departments that are staffed with roughly 30 plus members as well. You know, so if we have a large structure fire here in Okoboji, 10 years ago was tweeters. That far, you know, 10 years ago we had tweeters. They called, you know, they had a full, you know, they had probably 12 members of their own there. They called Milford, called Spirit Lake, you know, well, you're just adding another 12 to 24 members from, you know, each department combined. So now you take and you got 36 members. Well, if you have enough people on hand, you have the ability, while extinguishment is going on in another area, to now work on salvage in areas that may or may not have already been decimated by the fire, you know, removing pictures, you know, in house fires alone. I tell you what, you want to make a family happy, they're in a state of shock as it is. You want to make a family happy, go into a room that has not been impinged on fire, where you're starting to get some smoke going into, and start pulling picture family albums, computers, any electronics, all those things, that those memories that they may not have. If you can get them out and start handing them to the family while everything's going on, their outlook of what's going on improves just that much more. So, and ventilation is going to increase the speed of the fire extinguishment because we're pushing the heat out, so we're lessening the heat side of the tetraheater, and we're getting rid of the smoke, we're getting rid of some of that fuel with that smoke. So it allows us to get to it faster and put it out. The first part. No? So let's identify some considerations that are going to affect our ventilate. And then we're going to explain the critical fire behavior indicators present during the tactical ventilation. So both occupants and firefighters are at risk in a structure fire. That's pretty much an obvious. That's a duh moment right there, and I'm glad they put that up there because, you know, none of us knew that that's the whole, you know, the whole fear of everything. Is they had no idea we were in danger, right? So occupant life hazards increase lower if they're awake, for obvious reasons. They're awake, they smell something, they hear something, something's not right, they're able to get out, call 911, and obviously several possibilities if they're asleep. You know, you're hoping that the smoke alarm, smoke detectors are working. You hope that, you know, they have them in the right locations. Well, you know, firefighters' expected hazard for us, you know, heavy smoke, so we're going to have visual impairments. Lack of oxygen. That's the reason we wear SCBAs and we don't take them off until we're completely done, including during overhaul. Okay? Because we have that presence of toxic and flammable gases that we've talked about a multiple number of times. You know, and rapid fire development is possible. You know, if we do something wrong, we take a risk of causing the fire to develop a lot faster and put us in a huge hazard. So we've had, as we discussed through building construction, there's a lot of different building constructions that can present different types of risk during the fire. Obviously, residential structures and lot sizes are going to be different. You know, you could have a 900 square foot house or a 1900 square foot house, and we all know that the greater the space, the greater the potential, the more stuff that got in it. You know, the layout. Then there's the slide coming up will show you a layout from old style houses to new style houses. The materials, and we discussed this back in chapter 4 and 5. You know, back when my house was built in 1920, they used 2x4s, and I mean 2x4. You know, and now what are they using for rafters and, you know, all the bracing material? Pressed wood, glues, stuff like that. So as we discussed about fire behavior, when it's dealing with heavier wood, it takes longer to burn. It's not as hot. The new stuff out there now, it burns faster, it burns hotter. Energy conservation measures. So what are they talking about with energy conservation measures in the new construction? Old houses do what? They breathe, they leak. New houses, they're buttoned up so tight that, you know, you get a block of the intake, and, you know, we've got another problem there that they're dealing with. But these new houses don't breathe, so that fire's sitting there, and it's just trying to build, and we open a door to make entry, and what do we do to it? Fed it. So, open plan commercial structures. Anything from strip malls to shopping centers, and plastics, synthetic materials are being used now. The idea of recycling is out there. We're getting it pushed on us a lot, and I have no problem with it. However, it does cause a problem when we're dealing with fires because of the way it reacts. So here's that slide I was talking about when we're talking about how we can make a decision during our ventilation based on an old style house to a new style house. So in the old style, you had a hallway down, every place had a door, most of them had doorway, they all had doorways, but they had doors in most of them for the bedrooms. Now the new style houses, it's the new open floor plan, even my house is more of this way. But that's only because of the remodel that they did where they took out the wall for the master bedroom and built a new master bedroom. So I've got a huge open space between my living room, dining room, and fireplace room. And my kitchen's kind of on its own little thing now. So, obviously when we're talking about ventilation, if we're going to ventilate the old style, we're able to isolate, start closing doors. Where the new style, we can close doors, but we got a bigger open structure that's going to cause us more problems with heat and rollover, which eminently could turn into flashover if we don't get to it in time. So things we need to consider for ventilation. Occupancy classifications, like I said, is it a single family structure? Is it a multi-dwelling structure? Obviously the construction type, the floor area, the compartmentation, ceiling height's an issue. And remember in ceiling heights, especially in commercial structures, what do they do with those ceilings? What are they putting into them that could cause us an issue? Drop ceilings. So, the ceiling height we may see the ceiling height initially as a 10-foot ceiling, but it's a drop ceiling, so the actual height could be 12 foot. Number of stories. Is it in multifamily dwellings, is it just a one-level apartment complex, or is it a 2-level or 3-level like we have here down in Arnold's Park? Right behind the Mexican restaurant, we have a 3-story multi-dwelling matchbox, basically. Or who hasn't been to the Emporium? That's a matchstick on waiting is what that one is. And that's, 3 stories, 4 stories actually, because you got the basement where the bar's at. You got the lower level shopping area. You got the upper level shopping area. And then from there's actually an apartment up above it that overlooks the lake. So, that's one of those that, we know because we've done a survey of the area and we know that structure and we know that it's an imminent possibility. It's not a if it is going to, it's almost for us, it's kind of a win, I think. I don't know, maybe I feel that way, I don't know. You guys over there, I don't know. Is it an if or a win for you guys, for the Emporium?
Yeah, it's bad.
If the lake doesn't get it first, it's going to burn. So,
We almost did.
what, the lake?
No, the Emporium.
The Emporium?
We did have a fire there, was that?
A couple of years ago.
Summers ago.
Yeah.
And we got a cigarette outside.
Yep.
Fire on the structure.
Yep.
Luckily somebody put it out.
Yeah. Because that building is 19.
It's got all kinds of void spaces and
Yeah.
it's bad.
Yeah, that's one of those when I talk about pre-plan. That's one they've pre-planned here many moons ago, and
It's not a whole lot I think you could do there.
surrounded around, protect the structure, protect the condos to the one side of it, and protect the house on the other side if you have an opportunity. So, and we're going to look at the number of and the size of exterior windows, the doors, other wall, staircases, elevators, shafts, any dumbwaiters that may be, ducts, obviously roof openings. We got to think about external exposures that we may have to deal with. Once again, here, we got houses that are 5 feet apart in some areas. At least that's what it seems like. I swear that some mornings the neighbors open up the windows and shake hands and tell each other good morning. So nice big house and no lawn. You know, connection to adjoining structures. You know, in a single family housing dwelling area, you might have a breezeway. You know, if it gets into the garage, does it get through the breezeway, get to the house? Hog confinements. You know, they're all connected. You know, so it gets into one of the hog confinement barns, works its way through that one, runs through a breezeway, gets into the next one. You know, we discussed roof styles in our last lecture with me. You know, what kind of type and design of roof are we dealing with? Is it a flat roof, a gabled roof? You know, knowing where our location is of our fire protection systems. You know, do they have one? If they do, where's our connection at? How does it work? Does it have an interior sprinkler system? Do we know where it's at? Do we know how to discontinue it or shut it off if need be? You know, what contents are in there? You know, obviously most single family dwellings, but to be honest, what I have in my house for my contents may not be what, you know, Butch Parks has in his house for contents. Mine's going to be the cheaper pressed wood glued together, and his is going to be the fancy dancy, you know, high-end oak and everything else. You know, and understand their HVAC system. Are they roof mounted in commercial structures, or are they mounted behind the building? Are they mounted on the side of the building up in the air? I'm trying to think of one off the top of my head that I had a pizza ranch that I delivered to that you literally walked underneath. The HVAC system sat up on a shelving up above the back door that you would walk under to deliver into the back door. And you know, it's something that, you know, if we know about, we need to be very aware about, so that we don't have to worry about that. The zippers fire. I was in the zippers fire with another guy, and we were just tooting right along, having a good old time, busting down a wall to put a fire out, and pretty soon we got told to clear out. Well, we couldn't see it, but the APO unit up in the air, in the aerial, there was an HVAC system right above our heads. And probably within 5 minutes of us getting out, it fell. So, you know, it's not something we thought about at the time, but it's something that, you know, somebody else had our six on.
I've seen them above drop ceilings.
Yeah.
In the attic.
Yeah, brace systems up there where they're on rods and holders up there to hold them up. Just personal garages. You know, I've got a heated garage in my house, and it's just 4 rods that run up through the system that are mounted to the roof, but it's right above. You walk in my garage door, and it's right above you when you walk in. So several fire behaviors indicators. That's also going to help with our planning for ventilation. You know, we need to look in and know at what our smoke is doing, what it's telling us. You know, in the picture we've got here on the left-hand side, I can tell you that it's some pretty nasty stuff coming out the front. And then you've got some pretty white smoke coming up around the eaves and through the roof. So it tells me whatever's burning is probably pretty close to the front door. Probably burning a lot of synthetics, stuff like that. It looks like it's pretty nasty looking smoke. And then as it's going through the structure, it's getting into some other more cleaner burning materials. The weather might be a little cooler as well, causing us a little bit wider smoke. You know, you've got your airflow indicators that we need to worry about. Windows go open, so fresh air is coming in, feeding the fire from underneath, causing all the heat and the smoke to rise to the roof. Now that D side of the structure doesn't necessarily tell us that that is the only feasible spot that the fire is located. You know, what it may tell us is that that's just at that point in time where it's at as we're ready to start our ventilation or to make entry. We don't know at that point where it started, what path it has taken, or anything like that. So anytime you're on a scene, if it's your due pleasure to be the first on crew or first due in engine, you know, that is your job. You got to determine its size, its location, and what extent of the fire has gotten to at that point in time. You know, if we try any uncoordinated ventilation at that point in time, we can take the risk of spreading that fire, or we can cut off and escape. The severity, the extent of the fire is going to depend on several different factors, and we've discussed a lot of those in repetitive form already, so I'm not really going to try and have to go over all that again. You know, primary consideration with the fire itself is which phase is it in. Obviously, it makes a difference in ventilation. Are we going to ventilate a fire that's still in its incipient stage? Probably not the fire, but what are we going to ventilate after? Smoke. You know, when we can do it in two different forms, and we'll discuss that a little later between negative and positive pressure. You know, but obviously, if it's gone into its fully developed stage, that is a situation where we may want to look at doing some ventilation prior to making entry to reduce that heat, to get that smoke out of there, to give that first in attack crew the ability to get in there a little faster and get a harder hit on it, rather than taking the time to try and crawl through and try and figure out where it's at. Obviously, it's going to depend on several factors. Discussed it multiple times already, but we got to talk about coordination with other operations. We're going to talk about coordination between using positive pressure fans, between breaking windows, between cutting holes in the roof. You know, this is all going to be done and set up before the order is given, and ultimately it's IC's job to determine if it's necessary or not. The weight is always on their shoulders. We're going to check our conditions upon arrival. And conditions can be not only what we can see inside for size, location, you know, where the fire is at, but outside indicators as well. Which way is the wind coming from? What's the weather, you know, is it humid outside? Because that's going to affect things as well in fire behavior, humidity. You know, you're also looking at talking about things like, is it cold outside? Is it hot outside? So obviously the type of ventilation we're going to use is going to be it's got to be appropriate for the situation that we're going to use it on. You know, it may not be appropriate to use a positive pressure fan. It may just be appropriate at that time to have to cut a hole in the roof. Or it may not be appropriate to cut a hole in the roof because the fire is not that extensive, and all we need to do is just put a fan on it, maybe use a little bit of Mother Nature's air, and clear it out that way. And anything that we choose to do has got to be capable of exhausting the volume. And we're going to talk about that a little bit later when we talk about using positive pressure and trying to force it against Mother Nature and stuff like that. So the location of the ventilation has got to be based on several different factors. Factor number one is going to be the location of the occupants if it is known. If we don't know where they're at, the best we can do is assume that we know where they're at, and always assume that they're in the worst possible location possible, because then if they're not, you have a better chance of survival. You know, exiting roof openings. You know, in a multi-dwelling structure is, you know, and obviously not here in northwest Iowa, but in larger areas, is there roof openings, skylights, stuff like that. Do we have the desired airflow path that we're going to want? And are we sure that we're going to be able to put that airflow in that direction? Or are we going to have to be dealing with fire doors that may have closed or situations like that? Building construction's got to be something we need to have as a factor as well. Single family structure, open layout, multi-dwelling with elevators and stairwells. You know, I just said it a little bit ago, Mother Nature and her wind direction plays a major factor when we start talking about positive pressure ventilation and negative pressure for that fact, because we're not going to beat her. You know, her 10 mile per hour wind that she blows is going to overpower anything that we have for a ventilation fan. The extent of the fire's progress, we've talked about that a few times, how far, what stage is it in. And the condition of the building and the contents. Is it a newer structure? Is it a structure that's been not decapitated, wow, I'm gonna cut the head off of everything. You know, is it a building that's just worn down, you know? And when you're talking about all of this, and it'll get said multiple times as we go through other lectures, is it worth the risk? You know, obviously that's something you'll always face when we're into this. You know, is that building been run down and nobody's lived there for years? Is it really worth our lives to go in and put a building that they're just gonna tear down anyway, or are we just better off just doing a defensive method where we just kind of stand outside and put a little water on it, put on a good show, and let it basically burn itself down to the ground and make it easier for the construction guys to clean up? Or is it, you know, a newer building that life is at risk and we need to go ahead and try and do everything we can to save it? Potential for structural collapse, we talked about that through building structure and fire behavior. Looking at the indicators of the building and seeing things that we need to be aware of, and knowing what type of building it is, whether it's, you know, a 1, a 2, a 3, up to a 5. And what effect that fire is going to have on that building construction. The effect it's going to have on exposures. We talk about garages. How many times do you hear a garage fire that's now impinged on the house, and now you're dealing with a house fire as well? You know, readiness of the crew. You know, when that first engine rolls up, do you guys get out fully packed up, or do you guys go on air when you get to the door? You know, it all kind of matters on your readiness, on how fast you can do things, especially on the ventilation side. So, you know, if that first crew out, you know, if you've got, you know, 6 guys on your first new pumper, so everybody's got a task when they show up, right? Obviously the driver's the driver, he's also the pump operator. Guy in the front passenger seat, he's the officer, he's the MIC, he's the MFIC until the chief has arrived, okay? Unless he already is the chief or doesn't want to give it up. So you got 4 guys in back. They all know their duties. You know, you go into an urban or an in-town structure fire, probably 2 of them are responsible for hydrant. 2 of them then get there. Maybe they're responsible for pulling hose line. So they get their hose line pulled to the front door. IC's done his 360. He's walked the structure. He's determined, he knows the location of the fire. He knows there's no occupants inside. He knows the fire in itself, how far it is into its stage, what stage it's in. He thinks he's determined that. And at that point in time, maybe he's determined that he wants to do ventilation before he lets that team enter. So your team that's now done the hydrant hookup and has got water to the truck, maybe now it's their job to either grab a ventilation fan, go to the front door, or maybe it's their job to grab a saw, grab a roof ladder and a tool, and they're going to head to the roof. So it's all coordinated. Everybody's got to be ready. They got to know what their jobs are, and that's stuff that we should train on a semi-regular basis, so that it's not a surprise when we pull up and the chief asks us to do something and it's not something we're ready to do or know what to do. You know, do we have the ability to protect the exposures that are around the structure that we're dealing with anyway? You know, can we protect the house next door, and what are we going to do to protect that house? Can we use ventilation to protect that house? And believe it or not, you can. You can pressurize a neighboring structure with a ventilation fan, and that will help protect that structure when you're dealing with structures that are so close. And obviously protecting the means of egress and access. Well, if we're going to do ventilation through the front door, we need to make sure that everything's working in coordination with the team inside, so that they always have a way back out. Weather conditions are going to have a factor on the building as well. How many openings that building has, what side of the building those openings are on, what other conditions that we deal with. You know, are we dealing with Are they doorways? Are they windows? And obviously one of the most important things we need to deal with when we're dealing with weather is the wind condition. And the wind is probably the most important because it can be a help to us or it can be a hindrance to us. I just said this a little bit ago, but a strong wind, and they say strong, I'm telling you, 10 miles an hour can overpower the natural convective effect of a fire and drive the smoke and the hot gases back into the building. A 10 mile per hour wind will overpower a ventilation fan. So exposures should be taken into account when planning ventilation. Internally, affected by the routing of the smoke. You know, which way are we going to send that smoke? What are we going to be dealing with? Which way we're sending it? What's going to be in the way? Are we going to have doorways that we need to worry about blocking open? Are we going to have just large structures that are going to impede it? You know, the best possible scenario is to have the best airflow, direct airflow possible to get all that smoke and heat out. And ventilation can create a danger inside. If done improperly, it can actually push the fire and actually bring it back around and block off the exits for your interior crew. Externally with ventilation, it's going to be affected by radiation and direct flame contact on any exposures that may be close enough, especially for radiation. That's why I'm talking about positive pressure ventilation on a nearby structure, because it'll help push the heat away. So it'll help affect or have a negative effect on the radiation, and obviously a negative effect on direct flame contact if you do it correctly as well. Why don't we go ahead and take a break? We've been sitting here for a little over an hour. Mike, I just have to hit pause, right? All right, back at it. So staffing and resources that are both requirements for ventilation. Resources that we're going to need. You're going to need forcible entry tools. Anything from a married pair. Does anybody know what a married pair is? What is it? Shaking your head back there.
It's a Halligan or an axe.
Yep. Flathead axe. Yep. So power saws, whether it be just a chainsaw or a K12. Fans or blowers, smoke ejectors, and there is a difference, and it discusses them in the chapter. Flexible ducting if you have the availability. Stacking and hanging devices, especially for the negative pressure, those fan ejectors. Power cords. Most fan ejectors are operated electrically, so you're going to need generators and power cords and other support systems that you may need to keep doorways open and stuff like that.
So the smoke ejectors, is that like a big air horn with a fan on it?
No, it's basically just a big box fan is all they are. So they're just a square box fan, and then you just plug them in, you'll hang them, and it'll show you hang them either on a ladder or sometimes you can get them with the window bracing. It basically looks like a spreader. It just sits in the doorway. You tighten them down, and then they just hang from that. And it's just an industrial size box fan. So in Injective 4 here, we're going to discuss horizontal and vertical ventilation. Means for achieving that. We're talking about the horizontal side, and it'll talk a little bit about this in a later slide. Notice the wind direction in the slide that we're looking at. From your vantage point, it's going from right to left. So, do we open up the right side first or the left side first? Left side. Yep. So we're gonna give it a way out first over there on the left side, whether it be from a window, another door, or if need be, you use your saws, using a K12 or using a power saw. We're going to cut an opening, start to allow some of that heat and that smoke out, and then we open up that right side, open up a door or a window. That fresh air pushes through, pushes that hot air and all those gases. Another version is vertical ventilation. It's the ventilating points above the fire, and we're going to channel the contaminated atmosphere out the top. So in the same scenario, you see at the top of the picture, they've got a hole cut in the roof. They've opened up the front door to let fresh air in. Key, if possible, what do we want to do first in this? Cut the roof or open the door? Cut the roof. Let that heat and stuff out. We talked a little bit about cutting that hole in the roof to let stuff out. What were we talking about before? What fire condition were we seeing as imminent that we want to cut that hole out first? If we thought backdraft was imminent because of the fire conditions that we were seeing, we would cut that hole first before we'd open up that front door. 3 different means that we can use to accomplish this: natural, using the wind; mechanical, using a fan; or hydraulic. And we'll learn how to do this as well in the simulator, where the crew inside, and usually what we're doing in this point in time is we've already made contact with the fire, we put the fire out, but we want to improve our visibility a little bit. So using the fire stream, we're going to use it to push some of that smoke out. So the need for mechanical or hydraulic ventilation, building or fire dictates other method is going to determine it. The location and the size is determined. The involved area is too large for natural ventilation. The fire's below ground, so natural won't work. Natural's just too slow. It's just not quite doing the job we need. Maybe there's just not really that much of a wind. Or maybe there's just too many structures around that's inhibiting the natural airflow to get us a good push out. And the layout's not conducive or to natural ventilation. So the basic means to accomplish ventilation: opening the hot side first, the downwind side instead of the upwind side first, opening up the hole, cutting a hole in the roof before we open up the front door. And determine which way we need, what we need to use. Are we going to use Mother Nature? Are we going to use mechanical? Are we going to use? So let's describe the types of ventilation. So ventilation can be applied to several different types of structures. One way is where the fire has not involved an attic or a cock loft. Because remember, when we're doing this, if the fire is up in the attic or the cock loft, it has no way to get out. So all you're doing by pushing air into it is just feeding that fire further and further in that attic and cock loft, and it's causing the fire to grow. Multi-story building, where the fire is below the top floor if the attic is uninvolved. Same idea. Who was that? Lake Park. That's right. It's a gas leak. It can't burn down downtown this time. Same idea. The fire's below the top floor. So if we try and do a hydraulic or a horizontal ventilation, all we're going to do is allow it to feed. The fire's going to go up instead of out. If the building's too weakened for vertical ventilation, it's got a bad roof to it, the walls are unstable. Building with a daylight basement, meaning that the basement is usable. It has the ability to get to the basement and grow down there. Or if the building is just ineffective for vertical ventilation. Here we're talking about the windward-leeward side, using conditions to take advantage of the natural airflow. So you can tell by the smoke, and that's one of your key factors as to which way the wind's blowing. We know based on this structure, if the fire was on the second story, It doesn't look like it has much of an attic or a cockloft area into it. Second story fire. We're gonna break out or take out or open up an opening on the leeward side. And then in use of that, once that's open, then we can go back to the windward side and open that. However, as you look at this structure, is there any way to open up the windward side? It's a concrete structure. There's no openings up there on the second story. So realistically, this is not conducive to good vertical or horizontal ventilation because you don't have the abilities because there's just no way to open it up. It just takes way too much effort to try and to bust a hole in that wall. Two types of mechanical horizontal ventilation. Picture on your left is that negative pressure ventilation. That's those box fans I was talking about. Here they're just taking the two holders. They're going to hang it from a ladder just outside the window. You can see the power cord is strung down and through, hooked into an extension cord. You can tell they're really concerned about the fire because it's plugged on the inside there. Once you've got that in place, usually towards the top or on the sides, and you can't get them wrong. There's actually an arrow on the top that tells you which way the wind flow is. The ones that I'm used to is it's just got a rod with a knob on the end of it, and when you're ready, you just pull it out. It turns it on. Fan starts up and does its job. Positive pressure ventilation, the one we're normally used to. Normally they're a gas-powered fan. We're going to put those at the doorway to assist Mother Nature, or to if Mother Nature's not going to be of a help to us. Notice they got that measured at 4 to 6 feet away. Why is that? Why don't we just put that right up to the door itself? Exhaust. Okay. Exhaust as the fan exhaust, or
The small engine exhaust.
that's one concern. And my former chief hated positive pressure fans for overhaul because of that reason. The real reason that you do it 4 to 6 feet away is you want that cone of air that's coming off of that fan to completely encapsulate that doorway. Because if it doesn't, if it only comes up to a certain portion, what gets out the top? Smoke. Where's our guys at? Right by the front door. So it's pushing that air in, it's pushing that heat and that smoke right back out the top. It's giving it that ability to get behind your interior attack crew. So negative pressure ventilation, the use of smoke ejectors to expel and pull smoke from a structure. We got to know the proper placements and the process. They're going to go in window openings. They always go on the leeward side. Properly sealed. And what they're talking about there is that at times you want to take a tarp and basically seal that window so that the only exit point is that fan, so that you don't get any turbulent air that comes out or comes down off the roof line, just like we deal with here in smoke or here in snow, where it comes over the top of the building and it just dumps down. Well, as the air comes over the top of the roof structure, it's going to dump down, and because of the pressure changes, it's going to suck itself in, and now it's feeding itself into the fire as well. We want to avoid opening windows, doors near that ejector. We just want the only exit point to be that ejector so that we know where the travel path is at every time. And getting obstacles, any large structures that may be in the way, entertainment centers, pianos, anything that could inhibit the good flow of air. And don't allow that ejector to be obstructed, which is, removing those obstacles. Obviously, understand the selection and the use. We're not going to carry it around when it's running. It just doesn't carry well. It's not safe. Check our cautions before starting. Make sure we know where our power cord is at. It's not a trip hazard. And that next line never did make any sense to me when I went over this a couple times. Avoid air discharge from and. From and what? So positive pressure ventilation fans can create slightly higher pressure inside the structure than outside. Basically what we're doing is we're just recreating what we do when we breathe. So all we want to do is we want to create, as it says, a higher pressure inside because it wants to equalize. So it wants to take that higher pressure and equalize it to the outer pressure. So in the first instance, the fire's up there in the top 2 floors. We've opened up a doorway up the top to give it as an exit point. Set up our fan, and because of the travel path, it pressurizes it and pushes it all out the top. Another more complicated way to do it, a more coordinated effort, obviously, is you can't get it to push out the top because of the roof structure. So we're trying to get the smoke and heat out. So we open up a window on the leeward side. We set up a positive pressure fan to help force that air out. And then we set up one at the main level at the bottom to push it all up. So it basically gets pushed up. And when it gets to the other fan, that fan pushes it back out. Improperly applied, positive pressure ventilation can change the interior conditions and injured personnel working from inside the structure. Meaning, if it's not done right, if it's not coordinated properly, if the fan's not set up like it's supposed to, you take an opportunity and a chance that once your crew gets inside that they're working, that you could, in theory, feed the fire behind them and cause an entrapment in their case. Advantages and disadvantages of positive pressure ventilation. One advantage is the setup. Setup's all done for the most part. It can be done outside. It is very effective when done properly. It's very efficient. Obviously, it must be efficient because they put it in there twice. Cleaning and maintenance is less. Because it's outside, you don't have to worry about the smoke and everything getting into it, keeping your fans clean. Maintenance, you're just doing small engine maintenance. Changing oil, putting gas in it. You can direct it. That fan can tilt up and down. It can move forward, backward. And it's a pressurized system is what we're going for. The disadvantage of it, the structure has to be intact. If you have any holes in the structure, any leaks in the structure, a poor structure in general, you're going to get smoke and fire coming out of places that you don't want. It may increase the carbon monoxide level because of the small engine run. Okay? And it may accelerate and spread any hidden fires that we weren't aware of. Because in theory it is feeding the fire, and if it doesn't have a way out, all it's going to do is cause it to grow. The thing on that too is make sure that your outside individuals know that you're about to do it. Okay? It's not a water stream that's going to knock anybody over, but it is one that they like to know so that anybody that's standing underneath isn't going to get deluged in, a whole lot of water in one short period of time. Especially when weather like this where it's cold outside. Next thing you know is he's standing at the back of the structure frozen solid because he can't move. So the main types of horizontal ventilation, there was 3 of them. What are they? Mechanical, hydraulic, natural. Yep. So, just a quick warning. You're never going to direct a fire stream into a vertical exhaust opening when there's interior fire truck crew inside the structure for obvious reasons. It's going to force that smoke, that heat, and that steam down on them and go completely against everything we're trying to do by getting it all out. I prefer, if I'm inside, I'd rather, unless I'm on fire, don't spray water in the same compartment that I'm in. because that's what you're doing. You're putting heat, you're putting steam into an environment that I'm trying to get out. Know what to expect when you're sounding a roof is important. If it sounds solid or if it sounds weakened, pay attention to the sound. It's difficult to hear at times because there's just so much going on and you're completely enclosed into the system. You can hear yourself breathing and everything else, but you can also feel it. So if it feels solid when you're hitting it, if you're a little unsure, hit it harder. Obviously, we always work in groups. We're always 2 in, 2 out minimum, sometimes 3 in, 3 out. When we're talking about working on roofs, we always need to be at least 2, but we don't want to be any more than we absolutely necessarily need because we don't want to put any undue weight on that roof line. Specific resources and skills when we're talking about cutting roofs. We got to ensure that the roof is safe. We do that by sounding on it, and we're only going to do the required openings that we need to make. Minimize any secondary damages. Try and not cut the rafters. I get it's going to be a high adrenaline situation, and especially with the K-12s, you may not feel it as much, but try and make sure because if there's minimal damage to the inside of the structure, well, all we're going to do is cause more problems for the homeowner if we go ahead and start cutting roof rafters. Coordinate it with the fire attack inside. Let them know that it's happening, especially when we start punching down through the ceiling. We don't want them below it. They're going to try and figure out who's knocking on their helmet. And make sure we have our safety of our personnel. We have our 2 points of egress. The size of opening we're going to use is going to be adequate. And as soon as we're done, we get down. So here it's talking about the kerf cut. I always got to look these up. Anybody find it? What's that?
I think it's 756.
You are talking where it talks about it?
Yeah.
Yeah, 756. Right at the top.
So kerf cut's basically just a quick single line cut just to see what's going on, see what kind of smoke and maybe fire might start coming in, pinging out on it. The other thing, the one that I mostly would use is going to be that triangle cut. It's exactly what it says. You just cut a quick triangle so you can get a look down in there, see what's going on. Offensive ventilation is going to depend on that roofing and the roof type. So whether or not you're going to do a square or rectangle cut, one opening is better than several small openings. It's easier to repair after the fire. So the square rectangle is the most common that we use, especially in a flat roof situation. As you can see there, and that's the tool I was talking about, the one that he's got in his hand. So basically what we've done is we've just created a rectangle cut. You push down on the one end so that you can grasp the other side, and you just roll it up on the nails to roll it up out of the way. So you got a nice large opening. Different types of roofs depends on different types of ventilation tactics. Depends on if we've got a pitched roof with a shingle covered, or if it's a pitched roof with a slate or tile covered. The shingle covered is going to be easier to cut than that slate or tile covered is going to be. Arch roofs, metal roofs. Metal's becoming the more prevalent into the area now, just because of the cost of it and the life expectancy of it. But in most situations that those metal roofs exist, they're directly mounted on top of the shingled roof. So you've got that small little void in there, so now you've had to cut through the metal, and then you have to go ahead and make another cut through the old single shingle covered roofs. Here's that trench cut. We're doing this strictly as a defensive ventilation method. We're just trying to get as much heat and smoke out as we can to avoid any further fire growing. Notice it's two long cuts, but then it's just they cut each piece into smaller sections, makes it easier to roll. Process. We're going to do it ahead of the fire, only after vertical ventilation opening has been made. We're going to make those two long parallel cuts, remove the roofing material, and then push that ceiling down. If we do it improperly, because we're standing on the hole or standing on the windward side, or it's going to put us as firefighters in a dangerous position, and it may cause the fire to spread more rapidly because we're going to give it some oxygen. Things that, as a ventilation team, we need to practice and be aware of. Plan ahead. Know where you're going to go up. Know where the fire's at. Know where your second point of egress has been already taken care of. We don't go up until that second point is already made for us. Know how we're going to cut our hole. Establish and maintain communication between each other as team members and between your commander, whether it's directly to IC or to one of your other officers. Obviously, one of you is going to be making the cut, going to be cutting the hole. The other one, you've got your head on a swivel, watching everything around. Before you go up, make sure you know exactly what you're supposed to do, where you're supposed to do it. Have a charged hose line present. Be very careful if you're going to take that charged hose line up the ladder. The best bet is if you can do it via aerial. It's a little safer that way. The reason I say be very aware of what that charged hose line on the ladder is going to do is, if you were to open the bail on a charged hose line on a ladder, what's the ladder going to do? It does this. Okay? That causes broken bones and a lot of pain. Actually happened to a member of APO 6 years ago. Erica. Yep. Erica was on a ladder, and they'd up the pressure for something else and didn't drop hers down. And she cracked that bad boy open, and that ladder went right off the house. She ended up with a severely broken wrist out of the deal. Obviously, we've discussed it. When we're up on that roof, it's full PPE, full SCBA, those two means of egress. Roof, somebody up there, we're always our own safety officers, but like I said, somebody's head's on a swivel. At any point in time, if he says no glory, operation's done, go to egress, get down. And cut that small inspection hole on both fire and the safe working side, so that you can see what's going on. Know the factors up against upsetting the vertical ventilation. What factors are we going to have that can affect and reduce the effectiveness? That ceiling, that's going to reduce the effectiveness. It's not a solution to all ventilation problems. You're not going to be able to get it all out, because just the area that you use it, or have placed that hole, that's great for maybe that compartment, but it does nothing for the compartment that's maybe 7 feet away from it that's barricaded by another wall. Something we stated earlier, and I reiterated it, don't throw a fire stream into a ventilation opening during offensive interior operations. You've got a crew in there, and all you're going to do is steam them. Other types of ventilations, such as basement fires. So the heat smoke wants to go upward. You will find if you ever get involved in doing a basement fire, if the fire and that smoke and that heat has no way out, its chimney is the stairwell. So what we want to try and do is to force that heat and smoke and fire out a different area so we can make entrance down the stairs. That could be taking out an egress window, putting a positive pressure fan at the top of the stairwell and pushing it away from us. Yes, it is very difficult to make access without ventilation because it's hot. You will find out in the attack simulator when we do the basement scenario, you will find out if you are on the hose line, you have to be very patient because you want to make a good hit on the fire, but if you get too ambitious and as soon as you get to the lower level and you put water on it, where's all that heat and steam go? It goes up the channel, and the third guy up there or the second guy up there, if he's not completely down, he will feel it. Other things you can do in basement fires for fire streams is if you have a cellar nozzle. Basically, it hooks to the end of a hose. And you cut a hole into the floor, and you drop that cellar nozzle down in the hole, and you put pressure to it, and it's got probably 8 different nozzles in it. And when it fires up, it spins, and just water everywhere. Works great to water pumpkins. Windowless buildings. Obviously, we're going to have multiple delays in those because you really don't have any way to get that to do any type of ventilation. It's very complicated trying to figure out how to get rid of the smoke and heat and everything else. Usually, it's going to have to be mechanical. You know, Mother Nature's not going to be much help. You're not going to be able to do much for ventilation, for hydraulic, and vertical ventilation is one of your only options if you can get a hole in the roof. And obviously, vertical ventilation's big on the mechanical side because it uses the PPV to enhance anything that the wind can do. High-rise fires. Big life safety situation. Gets that smoke out of there. It's going to push it up as high as possible. It's going to require a lot of people working in coordination with each other. But we have to consider that the smoke spread in the hot gas layer is going to develop because as it fills up, just like in a house, if it fills up that top layer, then it's going to move down to the next layer. And if we don't have everybody out of there yet, there's going to be issues of dealing with that as the life safety aspect of it. Things we need to consider during pre-incident plannings. Tactical ventilation is usually accomplished best by horizontal. Only one stairwell may penetrate all the way to the roof, so we need to be aware of which one it is. We've talked about closing doors, which doors to have open, which ones to have closed. You're going to have your fire doors. And that ventilation is going to draw that smoke and that fire up into the stairwell between the fire floor and the roof. And those positive pressure fans should be located at the bottom floor. Unless we have an instance where we did earlier in the slide presentation where we can use 2 to kind of help us push that air, that smoke and crap out. And those ventilation fans, as they keep running, are going to build up into the top of that stairwell. So we need to make sure that we've got it a way for it to exit out of there if possible. Here's a dull moment. If you're using a stairwell as a point of evacuation, you can't use it as a point of ventilation. So we'll talk a little bit real quick here about the effects of the building system on the tactical system. Modern HVAC systems are going to contribute to fire spread because of just the way that they're built, that they're running. They're big. They push a lot more air. The tubes are a little bit bigger. So there's usually a panel in the basement, somewhere on the ground level, that's going to control that system. And if you haven't gotten your electric shut off yet, they're going to be running. So all they're going to do is just keep feeding more air, more fresh air, more fresh air. And once we've shut it off, or once the power's been killed to it, it's not our job to turn it back on. Once the building's been deemed safe, then the building staff can worry about that. And as I said, the ductwork's going to cause additional fire damage just because of its location, how it's run. So here's a built-in smoke control system designed to confine fires. I don't know of any of these in our area.
Say most in this area have smoke dampers hooked to the fire alarm system. So when the fire alarm goes off, the dampers close.
Yep. Yeah. So instead of us having to do it, the system does it automatically. So, which helps in that HVAC system instead of. So, I'll have to ask my cousin if he knows of any. You know of any in the Sioux City area?
That have that.
Yeah, that have that.
deal?
Yeah.
Everything I've worked on has been the fire dampers.
The dampeners. I'll have to ask my cousin if he knows of any, if Western Iowa Tech's got them at all or not. He used to work for C.W. Suter. Now he works for a guy out of the Mulville area, but all they do is big industrial, Western Iowa Tech and stuff like that. So, don't attempt to use that operating system to assist in your ventilation. Well, I don't even know how they work, so I wouldn't be able to. Just start turning levers. Hey, it's green, it's red. So, quick summary. Tactical ventilation of a burning building allows the heat, the smoke, and the fire gases to escape to the atmosphere and also allows fresh air to be drawn into the building. When properly applied, tactical ventilation allows the firefighters to see better, locate victims more easily, and find the seat of the fire sooner for those reasons. If we can see better and we can get in there faster and not deal with the heat, we're going to find any life safety victims that we encounter. Tactical ventilation is going to limit the fire spread, and it's going to channel the heat and the smoke away from any of the tracked victims. However, it has to be correctly coordinated. If not, it can actually cause more harm than good. We have to understand the fire behavior, and we've talked about that. We discussed that in Chapter 5. And we need to know the various ventilation methods and have knowledge of the roof construction in any of the situations that we deal with. Know how to create exhaust openings in all types of roofs that we deal with, and have a variety of openings in order to perform that ventilation correctly, whether it be a rectangle, a box, a trench, making sure that we always put our viewing holes in first. And then there's learning objectives. We'll do this as some of the skills part, ventilating using a mechanical negative pressure in a window. That's something we can do in the trailer. We can do that in doorway. Doorway is more where you're going to use the fan or use the tarp. And actually, doorways work really well because you can stack them. So you can stack probably 3 negative pressure fans on top of each other and really create a good draw. Positive pressure. If you guys have an opportunity at whether it, not training night, but, here for APO when we do truck checks, if you guys do truck checks or all, do you guys fire up your PPVs as part of your truck checks? No? Do you do truck checks?
I don't think so.
Okay. Well,
I don't really know.
we do ours on business meeting nights. So every night at business meeting, we come in, and the first thing we do is we're assigned to certain trucks and that crew. So if Mike is the officer for that truck, then he and Jed and Jose and we all go to that truck. And we make sure that all the equipment is present, make sure that it's clean, in good working order. We start the saws, we start the PPV vans. So we know how they, make sure that they're running properly. That's an instance where you guys can take that fan, take it to a doorway, fire it up, and find exactly where that limit is, where you think it would be to get that cone around that doorway and get that proper placement so that you can actually With an ungloved hand, you could put your hand at the top corner and you can feel air all the way around. It'll go over it later in some of the lectures, but when you're talking about cutting holes in a roof, whether you're taking a K-12 up or you're taking up just a saw, an important key note on that is start the saw first on the ground. Make sure it starts, shut it off, take it up, restart it on the roof. Okay? Because you don't want to get on the roof and have it not start. So always start them on the ground first, shut them off, because another dumb moment, don't climb a ladder with a running saw. It's a dumb moment, but you know what? There's a warning label out there somewhere because somebody done did it. Obviously, I told you we're going to go ahead and perform hydraulic ventilation. We'll do that in the trailer as well. Demonstrate the procedure for sounding a roof. You can do that just on the ground. Just take an axe and just every step you take, sound it out first. Ventilate using a rotary saw to cut an opening. We'll see how much time we have with the trailer. The trailer actually has the ability to do those cuts where you can actually get on a ladder and it has a roof prop on it that we can put sheets of plywood up on it, and then you guys can actually go up and make those cuts. So we also call it the pumpkin launcher. it's pneumatic. The lift is on the roof. It's pneumatic, so it's got to build its pressure. So it stays there and it's building pressure. When it finally gets the pressure to open to lift it, it lifts it like very quickly. So we could also call it a probe ejector, but oh shit, I'm the probing, aren't I? Oh. Ventilate using an axe to cut an opening. It takes a while, but it can be done. Same idea. You're just gonna use that axe to cut that line. We'll demonstrate flat open. We talked about it in here. Okay. So from your point of egress, you're going to make your top cut, the furthest cut away from you first, then the second one, and then either the bottom or down is 3 and 4. Punch it out, grab and roll it. Pike pull is what most of us would use up there. If you have a Clemens hook, they work really well to do that, to grab and pull. And what else do we need to make sure we've done once we've opened up the roof? What do we need to do? Punch the ceiling.